So we'll do an example of system of linear inequalities, graphing system of linear inequalities in the context of a word problem. So sometimes, or what I've found from adult and young students in the past is that once you get the hang of doing the graphs and shading the graphs, interpreting the world, interpreting a real world situation, and writing it as inequality can sometimes be the most difficult part. So I wanted to do one further example of that. So you have the situation, selling tickets to a school play. It says the school requires that there are more adults than children in the auditorium, which can hold up to 200 people. I'm going to stop there at that second sentence. So the school requires that there are more adults than children in the auditorium, and that can hold up to 200 people. So there's a lot in that one sentence. So I'm going to go over to my document camera here in just a second. But more adults than children, that is an inequality right there. If it talks about more of this or less of that, we can write that as an inequality. So I'm going to use A and C as my variables for adults and children. So I've got more adults than children. So whatever the adults are, I know that this isn't very zoomed in, but there's a purpose for that. Whatever the adults are, that has to be more than the children. More adults than children. You can't have more children than adults in this particular auditorium for whatever reason. It doesn't say that it could be equal. It says there has to be more. So we're going to have a dashed line. There's no equal there. It's just the adults are more than the children. It also said that the auditorium could hold at most 200 people. So it could hold less than 200 people, 5 people it could handle. It could hold exactly 200 people, but it couldn't hold more than 200 people. So if we combine the adults and the children together, the adults plus the children, we should have less than or equal to, because again, 5 children and 6 adults would be fine, 200. All right, so we've already got 2 inequalities. Let's go back to the situation here. It can hold up to 200 people. You need to sell at least $600 worth of tickets. So far, we have not dealt with money. The children and the adults have just been people, and we're counting people and counting adults versus children. Now we're starting to talk about a value for those people. So we're putting a value on people today. Adult tickets are $5 each. So adults have a value of $5, and children's tickets are $3 each. Children have a value of $3. So adults are valued higher than children, but their value together would have to be $600. Or they want to make $600. They could make more. If they made $1,000, that'd be great. $1 billion. More than 600 is okay, but they need to sell at least $600 worth of tickets. All right, so let's look at that value in the form of an inequality. So it was $5 for the adults. So I'm going to say $5 times each adult. And if I combine that with $3 for each child, they're okay having exactly 600, but they'd be happier with more than 600. So at least means greater than or equal to, at most or up to 200 people, less than or equal to. All right, so I've got my 3 inequalities. It doesn't matter which one I solve for. I guess when I say that, I should say it doesn't matter which one I assign to be the x and which one I assign to be the y-axis, as long as I pick one. I'm going to choose the adults to be on the y-axis and the children to be on the x-axis. So I'll label this right now children. And then A is already isolated here. A is greater than C. I don't have it isolated here though. So I'm going to subtract C from both sides. So I'm going to get A less than or equal to 200 minus C. And here again, I need to get A by itself. So I'm going to subtract 3C from both sides. I'm going to divide by 5. And I'm going to get A is greater than or equal to, I divided by a positive 5. So we don't have to worry about flipping the sign. 200 minus 3/5 C. Again, if I subtract 3C, 600 divided by 5 is 200, and 3 divided by 5 is Now you'll notice I don't quite have those in slope-intercept form, simply because I didn't put the variable before the y-intercept, but I'm going to leave it because it doesn't really matter as long as I can graph it, because it didn't say write it in slope-intercept form, it just said graph it. Or that's what they're asking us to do anyways. Okay, the graphing. I've got my three inequalities. A is greater than C. So if these are my adults, I should probably label this adult. So I've got my adults, I've got my children, and now I can graph. A is greater than C. So really this is like y is greater than x, the slope is 1, and the y-intercept would be 0. It's a dashed line because it didn't say in the problem that we could have an equal number of adults and children. It had to be greater. So I'm going to use a ruler, since I'm doing this on paper and I don't have a computer to help me. And I want to have a slope of 1 with a dashed line here. There we go. Okay, so I've graphed that line, dashed line, and I'm going to shade above the line. So I'm going to go because y is greater than c. There we go. All right, now I've got 200 minus c. So the y-intercept is 200. The slope is -1. So I've got my y-intercept of 200 here, and I have a slope of -1. So down 1 over 1. Just to use the ruler and use my thinking a little bit, I know that if it goes down 1 over 1 the whole way, it's going to end up down here at 200 as an x-intercept. This is a solid line, so I can connect that using a solid line. There we go. And it says that A is less than this line. So all the adults below that line will work. So I'm going to go the other way with my lines. That way I can see where they overlap in this checkered area. And the last inequality, A is greater than or equal to 200 minus 3/5 C. So again, y-intercept of 200, slope of -3/5. So y-intercept 200, slope of -3/5. So let's see, that would be like down 30 over 50, because I'm going by tens here. It looks like 10, 20, 30, 40, 50. Yep. So down 10, 20, 30 over 10, 20, 30, 40, 50. There we go, right there. Oh, I'm sorry. As I'm doing this, I'm going, that doesn't seem right. Let me double check my mental math here. I think 600 divided by 5, not 200. So if you saw that and went, wait a minute, you were right. 600 divided by 5 down here. When I solve for A, and I divided by 5, 600 divided by 5 is 120. So I made a mistake, and as I was graphing, it felt wrong, which is not a very mathematical thing to say, but it felt wrong. So I double checked my math, and sure enough, my mental math was wrong. 600 divided by 5 is not 200. 1,000 divided by 5, right? Wouldn't that be one? It's a Monday. Yeah, 1,000 divided by 5 would be 200. So 600 divided by 5, 120. So my y-intercept, so this point right there is wrong. 100, 110, 120. There's my y-intercept. Now I can go down 30 over 5. 10, 20, 30 over 50. Down 10, 20, 30 over 50. 10, 20, 30 over 50. 10, 20, 30 over 50. Okay. X-intercept is 200. So I'm going to connect my dots here that I made. Again, this is a solid line, because they could make exactly $600 and they'd be okay with it. More would be better though. So I'm going to shade above the line. And this is where I'm kind of running out of directions to go with my shading, but I'm also at the end of my shading. So I want this to be above the line. and below this line and above this line. So my three inequalities here, I want to be above, so I'm going to be on this, but I'm going to stop at this dashed line here because I know I have to be above that line. I know I have to be below this line because that was my second inequality. So really I'm looking at this section right in here. So if I'm selling these tickets, I'm trying to figure out what do I need to shoot for. I need to sell some combination of children and adults that's in this region here. 100 children and 100 adults wouldn't work, so 99 children or 101 maybe. But somewhere in this region is going to give me more than $600. It'll still fit in the auditorium, and there'll be more adults than children. So that's kind of the process that you need to go through when you're graphing these multiple inequality graphs.